In this question, they've got a curve and a point, and they want us to find the normal at that point and show that it's 5x plus 2y equals 27. So let's get a little visual of this. I'm going to go to Desmos and graph this really quickly. It's a rational function, so you'll notice how there's asymptotes here. And what's going to happen is at this point, let's see, what was it, 5, 1. Now, there's going to be a perpendicular line that's going to go from that point. Our job is to find the equation of that line. So, we've got a curve, and if we were to take this curve and find its derivative, we could find the tangent slope, and then we could find the normal slope. So the first thing I'm going to do is I'm going to rewrite this so the x power is in the numerator. When I find the derivative, I'm going to use the power rule, and that gives me 10x to the negative second. And if I rewrite that, bringing the power down to the denominator, it's 10 over x squared. Now, the tangent line slope is going to be 10 over 5 squared, because x equals 5 at the point that we're talking about. And that gives us a tangent slope of 2 over 5. Now remember, we don't want that slope. We want the normal slope. So we're going to take the opposite, make it negative, and then flip it upside down, the reciprocal. Now we've got a slope, perpendicular slope, and we've got a point. So all I'm going to do now is find the equation of the line by substituting the x and the y of my point, and then finding the y-intercept. I go ahead and clean this up a little bit. I'm going to get the b by itself. I can rewrite this as 2 over 2, so then when I add, I get 27 over 2. That gives me a y-intercept of an equation of negative 5 over 2x plus 27 over 2. And then if I multiply everything by 2, you see I end up with 5x plus 2y equals 27, which is what they wanted me to do. Now in part B, they want us to find the coordinates of point Q. Q is where the normal meets the curve again. So our perpendicular line goes through the point on the lower part of the graph, and then it's going to go to the upper part of the graph and touch another point. That's point Q. That's the point we've got to find. So let's get to it. The normal equation is 5x plus 2y equals 27. And the curve is y equals 3 minus 10 over x. Well, Q is where these two curves intersect. And so all I've got to do is solve both of these simultaneously and find the x and the y where they intersect. So I notice that y is equal to 3 minus 10 over x, and I'm going to substitute that into the first equation, and I end up with this. And then all I'm going to do now is simplify, and at the end of the day, I'm trying to get my x by itself. Here you'll notice I have two fractions, so I'm going to create a common denominator. And then I'm going to multiply both sides by x. And then I've got a quadratic, and all I've got to do is solve it. If I solve it using the quadratic formula, it's going to look something like this. I'm going to write that down to show my method, but then I'm going to go to the calculator and I'm going to use menu A, and I'm going to solve this quadratic this way. So once I've got this set up, I find out that x is equal to 5 and negative 4/5. Well, we knew about the 5 already because the 0.51 is p. So this x equals 4/5, that must be the x value of q. So then if I substitute this back in the 4/5, I'm going to find out the y value. 5 times 0.8, I'm going to subtract that on both sides. Y is equal to 15.5. And so that's going to be point Q. And now all I've got to do is take these 2 points, and I've got to find the midpoint of them. And in order to do that, I'm just going to add the x's and divide by 2. That'll give me the x value of the midpoint. And I'm going to take the 2 y values and divide by 2, and that'll give me the y value of the midpoint. And so I end up with a midpoint of 2.1, 8.25. And then we're good to go. All right, thanks for watching.